From chapter 1, we discussed the statistical research process, which is shown here in this slide. And uh, before we can start with data analysis, as we have discussed from before, a necessary step is for us to perform data preparation and data cleaning. And data preparation involves the following. First, it involves cleaning the data, and this includes removing outliers, removing incomplete responses, and standardizing formats. So this is where we look at all the responses in the database, and then we try to check if all of those responses are valid. And if some responses are inaccurate or invalid, then we have to remove them or we have to correct them so that we will have good results once we start performing the statistical tools. And we can also perform data enrichment, which includes adding data derived from the clean data set. So if you have information such as the items bought, from there you can determine the amount spent. Or if you have information about the specific occupations of the respondents, we can add a separate column for broader categories for the occupations, like health professionals for all those in the same field, like doctors, nurses. They will all be classified into that field, which will make the categories more distinct and at the same time fewer as compared to the more specific ones. And once you're done with the data cleaning and enrichment, then we can start performing the data analysis. Here's an example of the database that we can use for data analysis. This is the Park and Blends database that was uploaded in the group. Here we have two worksheets. We have the first one, the raw data sheet, and the second one, the clean data sheet or the clean worksheet. Now, what I'll be showing you here is a simple way for us to clean the data set, and this involves going through each column in the dataset to determine if there are responses that are invalid or if there are responses that we have to fix. And to do that, we just have to click this one. So click the filter icon, which will show us all the unique responses for each column or for each category. So if you click that for here for occupational status, you'll see that the column contains three unique responses. We have employed, student, and unemployed. So since we can see here all the unique responses under this column, it will help us determine if some entries for this column are invalid or were incorrectly typed. And looking at the three unique responses here, there seems to be no problem. So we can proceed to the next column. And we will do this for all columns in the dataset. For gender, it's also similar. We only have F and M, so there seems to be no problem. Here for age, we have less than 16, greater than 33, 16 to 21. And there seems to be a problem because we have one entry here which is blank. And what can that suggest? It probably means that the respondent forgot to input his or her age, or maybe the respondent was able to provide the age, however, during the encoding for the data set, maybe the person forgot to type in the value here for the age. So how do we fix this? There are different ways for you to do that. First, since you have the contact details, maybe you can contact the respondent and ask for the actual age. Or if the error was in the encoding part, then maybe you can look for the actual survey and get the actual detail of that respondent. Or if there's really no other way for you to get the age of that respondent, then the suggestion is for you to remove not just this response, but the response of the entire person. So delete the entire row so that you won't be able to use any of these information in your analysis. So let's say here we were able to find the actual data and that the age of the person is 23. So in that case, this person will fall under 22 to 27. So we can just fix this and add the correct response. And then let's proceed to the others. For times visited, there seems to be a problem again here since some responses are overlapping. we have more than twice, and then we have thrice. And we know that thrice should be the same as, or should fall under more than twice. And more than twice is the more recurring response, which means that probably thrice was the incorrect value. So what we have to do here again is just edit this and then change this to more than twice so that the responses are non-overlapping or the responses are mutually exclusive. Here for the rate, these are the rankings for the main reason why the customer visited the establishment. So we just have to check if the responses here are all numbers since these are ranked. So we have here 1. Here for food, all the values are numbers. That's also the same for the price, for the ambience, and for the drinks, and even for proximity. So all the responses are numbers, so there seems to be no problem. Now for bought food, there are 2 responses only, either yes or no, so there seems to be no problem. For time spent inside the dog zone, we have the actual exact values for the time spent. So this becomes a quantitative variable. And here we also have something similar for the time spent outside the dog zone, which are exact values. Now, these 2 variables are considered as quantitative variables. They are inherently quantitative because they refer to time spent. And at the same time, we have the exact values, the actual time spent inside and outside the dog zone. Some quantitative variables become qualitative because of how we gather them and because of how we encode them. As shown earlier, we know that age technically is quantitative, but since we categorize the ages into different intervals, this effectively makes this variable qualitative. But since here, for the time spent inside and outside the dog zone, we have the exact values, then this is still considered as a quantitative variable. Now, for the state of dogs, we only have 2, so there seems to be no problem. And now for monthly household income, again, this is an example of a variable that should be quantitative, but since we have values here that are in intervals, then these are now considered qualitative. And there seems to be a problem again for this variable. We have 2 responses that refer to the same thing. We have 30,000 to 60,000 with commas and 30,000 to 60,000 without commas. And again, they refer to the same response, but they only differ in terms of the format. So Excel considers these as 2 different responses. So most of the responses don't have commas. So for us to fix this, then we'll just have to remove the comma for this response so that it will be considered as the same response with the others. So now we've fixed the intervals here, but again, this is still considered qualitative since we don't have the exact monthly household income of the respondents anymore. And finally, for the amount spent, we have here the exact values for the amount spent. So this is quantitative, and there seems to be no problem with the values. So this is a quick way for you to perform data cleaning, and once you're done with this part, then you can now start with your data analysis. So you can use the data set for you to come up with charts with different tables and for you to perform tests for relationships. The last 4 chapters are all about data mining, or different ways for us to test relationships between 2 different variables. And we were able to discuss an overview of this at the start of the semester, but now we will discuss how to actually perform these tests. We have the following tests that will be discussed. We have the 2 population hypothesis test. We have the one-way analysis of variance, chapter 12. We have the chi-square test for independence, and simple linear regression. Now, for different pairs of variables, there's usually just one appropriate test that you can perform for us to determine if there is a relationship between these variables. And the test that we can perform that is appropriate for a pair of variables depends on the type of the variables that are being tested. If you have 2 qualitative variables that you are testing, then the best tool is the chi-square test for independence. If there are two quantitative variables, then the best test is the simple linear regression. But if the variable is qualitative and another one is quantitative, we have two options. We have the two population hypothesis test or the one-way analysis of variance. Now, how do we know which one of the two should be used? For chapter 10, for two population hypothesis test, this is used if, again, you are testing the relationship between a quantitative and a qualitative variable. But for this case, the qualitative variable needs to have two treatments only. When we say treatment, this refers to a unique response of the variable. So if a variable has two unique responses only for that from all the respondents, then we can consider that as a qualitative variable with two treatments. And if ever you need to relate that with a quantitative variable, then the best tool is the two population hypothesis test. And two population hypothesis test has a lot of applications. Normally, this is done if you need to compare two different populations and you want to know if there is a difference between the averages of the two. But we will limit our discussion to testing the relationship of two variables, one qualitative and one quantitative. Now, this requires a hypothesized mean difference of 0. From the term itself, this is our estimate of the difference between the two averages. And what are those two averages? Those two averages are the average of the quantitative variable coming from the two treatments of the qualitative variable. For example, if the qualitative variable refers to the gender, the qualitative variable gender has just two treatments, as we have seen in the database earlier. We only have male and female. So if you have to relate that to a quantitative variable in the dataset, let's say time spent inside the dog zone, then the two population hypothesis test will just test if there is a relationship between the two by comparing the average time spent inside the dog zone by the males and the average time spent inside the dog zone of the females. So if we can show that the two averages are different, okay, if one is bigger or if one is lower, or if the two are just not the same, then that's enough for us to say that there is a relationship between the two variables. Because when we say that variables are related, it means that as one variable changes its value, then the other variable also has a change in its value. So in this case, if the gender changes from male to female and we can show that the time spent also changes, then it means that the two variables are related. Now, for two population hypothesis tests, there are two hypotheses. We have the null and the alternative, similar with the one population hypothesis test. And this is how we construct the hypotheses given that the hypothesized mean difference is 0. Basically, we're just trying to find out if the average for the first population is either greater than, less than, or not equal to the average of the second population. And since this is a hypothesis test, this will require sampling distributions that are normal. And since we are performing a two population hypothesis test, then the two sampling distributions for the sample means should both be normally distributed. And to determine if the sampling distributions are normal, then we just have to use the central limit theorem for both populations. And to prepare the data set for the analysis, we just have to come up with two different columns, wherein one column contains all the quantitative responses for the first population and another column for the second population. Now, for two population hypothesis tests, there are three types that we can choose from. You have the first one called the z-test, two sample for means, and this is used if the population standard deviations for both populations are known. So if you, in the example mentioned earlier, if you know the standard deviation for all the time spent of male customers, and you know the standard dev for all the time spent inside the dog zone of the female customers, then you have to perform the z-test, two sample for means. But if at least one of the two standard deviations is missing, then we can only perform either of these two t-tests. You have the t-test, two sample assuming equal variances, and t-test for two sample assuming unequal variances. The first one, the first t-test is used if We don't know both population standard deviations, but historical data shows that the two are the same. But for the last one, we use this, and this is more realistic, this is more practical. This is used if both population standard deviations are known, and you don't know if the standard deviations are the same or not. And in most cases, we will have to use this one because in most studies, we don't have population standard deviations, and we also don't know if the standard deviations of the populations are the same. In this part, I'll show you how to perform the test using the free software StatPlus, or for those who are using Windows, the built-in analysis tool pack in Excel. For us to perform the test, again, you have to have a clean data set. So let's use the clean worksheet for the Barkin Blends database. And then let's use the same example for this demonstration. So as mentioned earlier, we will try to test if there is a relationship between gender and time spent inside the dog zone. For us to do that, first you can segregate the two variables. Here, I'll copy all the values for the gender and then paste that on another worksheet. And then do the same for time spent inside the dog zone. So now that we have segregated the two, our next step is to prepare the data wherein we have one column for each population. And again here, the population depends on the two treatments for the qualitative variable. So the first population is for the male customers, and the second population is for the female customers. So here, our goal here is to construct a table that contains all the time spent by males, and then another column for all the time spent by females. And how do you do that? Here we can see that the first respondent is a male and spent 120 minutes, so we have to include 120 under the male column. And then for the next respondent, he's also a male, and then the time spent is 30, so we have to add 30 under this column. And then we'll just keep on doing that until we've covered all responses. Now for females, the first one is 75, so we have to put 75 here under female. And again, just do this for all the respondents. Now, a quicker way for us to do this is to use different features or different functions in Excel. You can try to filter the value so that you'll only see the time spent by a certain gender. And then you can just paste all those values to this column. Or you can just sort the value so that, again, you can still retain the same response from the same respondent. So for me to sort the dataset, I'll have to select the two columns, all the responses under this column, and then I'll sort in terms of the gender. So now we can see the responses first for the females, and as you can see here, again, the relationship between the two is intact. So it's the respondent who was female earlier with a time spent of 75 still has the same connection. They're still in the same row. So I'll just copy all these values for females and then paste that to the column for females, and then do that also for males. So here for the males, I've already pasted all the values, and as we can see here, the total number of respondents are not the same. Now for this case, it doesn't really matter if the number of responses for the two samples are not the same, since we did not really stratify the data gathering in terms of the gender. So even if the sample sizes are not the same, as long as the sampling distributions are normal, then we can still perform the test. And again, for us to check that, we just have to get the number of responses. For males, we have 39. For females, we have 61. So both sampling distributions are normal, thus we can perform the test. And how do we perform the test? So for StatPlus users, just open that application and then press Statistics, choose Basic Stat and Tables, and then here, since we don't have population standard deviations, then we have to perform the t-test. So just select this one, Comparing Means t-test, and then a dialog box will appear. For Windows users, just click the data analysis icon, and then a dialog box will appear which will show you all the different tests that you can choose from, and then select the correct test. And here, since again we don't know the population standard deviations and we don't have historical data, then the correct test is the t-test assuming unequal variances. So just select that, press OK, and a similar dialog box will appear. Here we just have to make our selection so that we can perform the test. We have to make a selection for the first population and then a selection for the second population. For the first population, the sample refers to all the males, so I'll just make a selection for all the responses under males. And then I'll do something similar for the second population, so I'll select the sample of female respondents and then just fill out the rest. For the means, the standard dev, and the sample size, you don't have to provide them anymore. We just have to set other values. Hypothesized mean difference, as mentioned earlier, should be 0. The alpha can be any value. You can use any value since later on we will just be using the p-value method. So you can set 10, 5, 2, 1, or 0.1%, but for me, I'll just use the default 1.5%. And then again, I'll have to select the t-test assuming unequal variances. So once you're done with the selections, here don't forget to make sure that the labels are checked, especially if your selection earlier included the labels. So my selection earlier included the column header male and female, so the two checkboxes here are checked. So now I'm done filling out the dialog box. I'll just press OK, and a new worksheet will appear which will show me all the necessary values for us to make conclusions. Here we have a table showing us the descriptive statistics about the two data sets. So the first one is for males and then the second one is for females. And we can see here some descriptions for these two samples. So for males, we got a sample size of 39 and the average was 110.8974 with a sample variance of 1291.93657. For the sample of 61 female respondents, we have an average of 107.1312 and a sample variance of 497.8825. Now, comparing the two sample means, it seems like the average for the males is bigger than the average for the females, and that's what we have to test now. Is the average for the males really bigger than the females? Or is the average for the males just different from the average for the females? Now, depending on what you want to find out, we have to select the correct p-value for us to make the interpretation. If your alternative hypothesis states that the average time spent of males is bigger than the average time spent of the females, then you have to check the p-value for a one-tailed distribution, which here is 28.01%. But if your alternative hypothesis states that the average time spent of the males is different or not equal to the average time spent of the females, then the correct p-value that you have to check is this one, p-level for two-tailed distribution. And if you compare these two p-values, you'll see that this p-value is just twice this p-value. Because remember, this is the p-value for two-tailed, so the p-value is just twice the one-tailed p-value. Now, since these two p-values are very high, they're both greater than 10%, then we have the same set of decisions for both. For one-sided greater than test, here the p-value is greater than 10%, so we can say that we don't have enough evidence to conclude or to support the claim that the average time spent inside the dog zone of male customers is greater than the average time spent inside the dog zone of the female customers. And if you use the two-tailed p-value, we have the p-value of 56.01%. And again, this is greater than 10%. So our conclusion here is that we don't have enough evidence to support the claim that the average time spent inside the dog zone of male customers is not equal or is not the same as the average time spent inside the dog zone of female customers. And since we were not able to show or we don't have enough evidence to say that the two are different, or that the average of the males is greater than the average of the females, then we can also conclude that we don't have enough evidence to support the claim that the two variables, gender and time spent inside the dog zone, are related. Since we can only say that the two variables are related if we can show that the average of one is greater than the average of another, or if the two averages are not equal. And that's a simple demonstration of the performance of this test. For other versions of StatPlus or for Windows users, the format of the table might be different, but the value should be the same. And you just have to look for these two important values so that you can make those interpretations.